Alright, let's look at our first problem from 10.4. Let's take a look at number 24. And what they're doing in number 24 is they're giving us some information and asking us to find the equation of the hyperbola. So they're giving us one of the focus points, and they're telling that is at 0, 6. They're giving us a vertice. Actually, they're giving us both vertices, and that one is at 0, -2, and the other is at 0, 2. So from that given information, which is in blue, we should be able to come up with the equation. Well, what do we know right now? We know our center is at 0, 0 because it's right in between the two vertices. We know everything's happening to the y. As we look at the change from the center to and the vertices, it's in the y. To the center to the focus, it's in the y. So it's our y that's first. So it's y minus k, which in this case is 0 squared, minus x minus h, which in this case is 0 squared, is equal to 1. And our job is to find out what a is and what b is so that we can do that. But we kind of have it. We know that a is the distance from the center to one of the vertices, and so a is 2, so a squared is 4. So now we know that, utilizing that distance. And so how are we going to get b squared? No problem. We know that c squared is equal to a squared plus b squared, so we know c squared is equal to, well, 4 plus b squared, but I stopped for a moment because we know what c is. C is the distance from the center to the focus point, so it's 6. So we know what c squared is. It's 36. 36 is equal to 4 plus b squared. So what's b squared? B squared is equal to 32. And so we have a nice 32 working out there. So notice that even though the b is bigger than the a, or in this case the b squared is bigger than the a squared, we still pay attention to who's the non-squared variable, and that should be the equation that would have given us, as stated in number 24, a focus at 0, 6 and two vertices at 0, -2 and 0, 2. So we have another one we'd like to see, and that is number 26, the very next one. So let's see what information they give us in 26. Well, they give us the two vertices, -4, 0 and 4, 0. Well, that tells us our center is at 0, 0. And then they give us one of the asymptotes, y is equal to 2 over x. Or sorry, y is equal to 2x, not 2 over x. So what do we know? We know our center is at 0, 0 because that's right in between those 2 points. We know everything's happening in the x direction, so this is an x squared and a minus y squared. And we know it's equal to 1. Those are the vertices, and so we know the distance from the center out to one of those vertices is 4, so there's a 16 under here. So what we don't know is what this b squared is. No problem. We don't know a focus point, so it would be pointless to just say, oh, well, Jensen taught me that if I have a squared, then I just use c squared. Well, we don't know what c is. Nothing in here tells me about the distance from the center to a focus. So what do we use? We use the fact that we know the slope. The slope was always, so this 2, the slope of the asymptote, so now we're going to use the asymptote. Its slope is always what's underneath y, square rooted, so b, all over what's underneath x, square rooted, 4. So what's b equal to? Well, clearly it's 8. And so if b is 8, then what you have is x squared over 16 minus y squared over b squared, which is 64, is equal to 1. And that is the equation of that hyperbola, utilizing the fact that the slope of the asymptote has to be the square root of what's underneath y over the square root of what's underneath x. That will always be the case, and that allows us to easily get what b is. And so this is the answer right there.